Welcome to the University of Missouri Fisher Delta Research Center Virtual Field Day. I'm Jim Heiser, Senior Research Associate and Weed Science Program Leader. Today, my topic is total residual grass control in dry-seeded delayed flood rice. In many cases, controlling a weed before you see it can be less frustrating than trying to control a rapidly growing, emerged weed that is already competing with your crop. In rice, there are several post-emergent herbicides available for grass control. However, several of our most problematic grass species, notably barnyard grass and springletop species, have developed resistance to one or more of these herbicides. In Missouri and neighboring states where rice is commonly produced, biotypes of these grasses have been documented to be resistant or tolerant to post-emergence herbicides propanil, facet, newpath, as well as ACCase inhibitors, clincher, and Ristar HT. In this study, we aim to determine which combination of pre- and post-emergence options with a residual component could be applied in an overlapping manner to provide season-long grass control. To eliminate issues with broadleaf and sedge weeds, an application of Grandstand R and Permit Plus was applied to the two-leaf rice growth stage. For this study, all plots, with the exception of the untreated checks, received an application of command just after planting. This was followed by early post-emergence applications in a single or two-way tank mix for all treatments. Treatments 9 through 22 were identical to treatments 3 to 8, but received a mid-post application of either grasp, regiment, or facet when facet was not applied in the early post application. This table illustrates which treatment numbers correspond to each early post and mid-post herbicides and application timing. Each treatment in a row received the same early post herbicide, while the color coding of the treatment numbers corresponds to the mid-post herbicide application. A black dash in the M-post herbicide column denotes that the black-colored treatment in that row did not have an M-post application. For example, Treatment 3 was Facet L applied early post, with no application occurring at the mid-post timing. Likewise, Treatment 13, shown in red, received the same Facet L application at the early post timing, but with a mid-post application of grasp, also shown in red. Again, all treatments had a pre-emergence application of command applied at planting. The next three graphs will be set up similarly. The percent grass control is shown on the vertical axis, while each treatment is listed on the horizontal axis. Early post and mid-post timings have been abbreviated as EP and MP in the treatment name. Same letters above the graph indicate no statistical difference in control. Compact colored boxes indicate low variability in the 4 replications of treatments, while elongated boxes indicate high variability in replications. These observations were made on June 10th, or 6 days prior to the early post applications. This shows fairly uniform control of Amazon springletop and barnyard grass. At this evaluation, only the pre-emergence application of command has been applied to all plots, with the exception of the untreated check. Note the scale on the left begins at 80% control. Low densities of grasses in the trial area were a limitation in this study. This graph shows grass control by treatment differences at the time of mid-post applications on July 1st. We can clearly see disparities in the amount of grass control provided by different early post treatments, as well as some variability by replication indicated by the elongated boxes in the graph. At this point, weed control has been provided by the pre- and early post applications. No grasp or regiment has been applied. Therefore, there should be 3 or 4 iterations of the same treatments as shown in the table on slide 4 with similar ratings. For the most part, there were few and minor differences observed when comparing the same base treatments, while differences in control obtained from different base treatments was in some cases reduced or enhanced compared to the untreated checks and the pre-only treatment. Please note that on this graph, the scale has been slightly changed to a minimum of 75% control. 4 weeks after the mid-post applications and flood establishment, we see nearly all treatments having grass control statistically similar to the best treatments. Only the untreated check, pre-only, Prout early post, and Bolero early post with no mid-post application can controlled grasses significantly less than the treatments which provided the best control. These were Bolero early post followed by Regiment mid-post, and Bolero plus Facet L early post followed by Regiment mid-post. There was quite a bit of variability in the observations in Treatment 5. 3 of the 4 applications had control ratings of greater than 95%. One plot rated 80% control. This may be due to unusually high grass pressure in this one plot, or more likely indicates an application issue such as not being sprayed or nozzle malfunction. Here we can see the extent of control for each treatment during the entire evaluation period. The dark blue bars represent control on June 10th, red on June 16th, light blue on July 1st, purple on July 15th, and green on July 28th. Percent control is shown on the x-axis and treatments shown on the y-axis. While differences in control under low weed densities were minor, we can see trends that should translate into situations with higher grass infestations. The command-only pre had a clear trend toward declining grass control throughout the evaluation period. Likewise, pre followed by early post treatments began to have worsening control ratings as the season progressed, indicating additional control was needed. Early post applications were applied on June 16th and mid-post applications on June 29th. Evaluations occurring on July 15th and July 28th clearly show the effectiveness of including the mid-post timing compared to pre followed by early post treatments. Many of the treatments that included an additional application at the mid-post timing either maintained good to excellent control of grasses or increased control through the end of evaluations. Controlling grasses in a rice crop is essential for producing high yields, minimizing competition with the crop, and allows for an easier harvest. Most producers do a good job of having command applied in a timely manner at planting. However, follow-up grass control can sometimes make or break a crop. The addition of another herbicide with soil residual activity for controlling grasses applied before there are many grass weeds present should be a best management practice for reducing the likelihood of uncontrolled grasses and reducing the likelihood of developing resistance to post-emergence only grass herbicides. The grass will be there. Control it before it becomes a problem. A cheap weed control program that results in a salvage treatment usually costs more than an expensive, properly executed weed control program. Overlapping residual herbicides has been shown to be an effective practice in other crops, and this should be no different in rice. I would like to thank my research specialist, Corey Cross, for his hard work and dedication for the past 6 seasons, as well as the Missouri Rice Research and Merchandising Council for funding this study. I hope you found this information useful, and thank you for viewing. Have a great day.